Hello and welcome. Today we're diving deep into the world of industrial automation. So, picture this, a factory floor just packed with pumps, sensors, and motors. They're all from different companies, some are decades old, some are brand new. So how in the world do you get them all to speak the same language? That's the puzzle we're putting together today. Let's get right into it. I mean, it's a really huge challenge, right? Without a common language, you don't have a smart factory. You just have a room full of silent, isolated machines. You can't monitor them, you can't control them, you certainly can't build a connected, efficient system. So how do you even begin to solve a problem like that?
Well, the answer came in the form of a protocol called Modbus. Honestly, think of it as the universal translator for industrial gear. It's simple, it's super reliable, and because it's an open standard, anybody can use it. This was just an elegant solution that became the bedrock for industrial communication. But it has two very distinct dialects, which brings us to our first section.
All right, let's start at the beginning with the original Modbus RTU, which stands for Remote Terminal Unit. This was the foundation, designed for a simpler time, using, well, simpler hardware.
The whole setup is pretty straightforward. You've got a single cable, usually an RS-485, that just daisy chains all the devices together. And on this network, there is one master, you can think of it as the manager, and it's the only one that can start conversations. All the other devices are slaves that just listen and only speak when they're spoken to. It's kind of like a private one-lane road where only one car can drive at a time.
So how does the data actually get transferred? It's a very structured, turn-based conversation. The master sends out a message for a specific slave like, "Hey, slave number 5, what's your current temperature?" Now, every single slave on that wire hears this message, but they all just ignore it, except for number 5. Slave 5 then processes the request and sends its answer right back to the master. Simple, orderly, and it just works.
Okay, so let's look at the actual message itself. It's a super efficient packet of binary data. Inside, you've got the slave's ID, a function code telling it what to do, the actual data, and, this is crucial, a 16-bit CRC checksum. Now that checksum is basically a fancy math problem that makes sure the message didn't get corrupted on its way. If the numbers don't add up correctly, the slave knows the message is bad and just tosses it out.
So with all this data flying down one wire, how does a device know when one message is ended and the next one is about to begin? Modbus RTU uses this brilliantly simple method: timing. Devices are literally listening for a pause, a silent gap on the line that lasts for at least the time it would take to send 3.5 characters. When it hears that silence, it knows the last message is done and it can get ready for whatever's next. Pretty clever, right?
But, technology never stands still. As factories evolved, the era of Ethernet arrived, and it brought incredible speed and scalability. Modbus had to adapt, or it was going to be left behind.
All of a sudden, that single wire, one conversation at a time model started to look like a major bottleneck. Modern factories needed multiple systems, like your main control system and maybe a separate monitoring display, to talk to the same device at the same time. That private road we talked about, it needed to become a superhighway.
And this is where Modbus TCP comes into the picture. The real genius here is that it doesn't reinvent the wheel. It takes the exact same core Modbus message we just talked about and simply wraps it inside a standard TCP/IP packet. It's like taking the same letter but putting it into a new, universally accepted envelope that the global postal system, in this case your Ethernet network, already knows exactly how to handle.
Okay, but using this new envelope does change a few things. First, that 16-bit CRC checksum, it's gone. And we'll see why in just a second. Second, a new header gets added, called the Mbps header. And this thing perfectly shows the protocol's evolution. Instead of relying on silent gaps in the conversation, this new header includes a length field that tells the receiving device exactly how long the message is. No more timing, no more guesswork.
So you might be wondering, if the CRC checksum is gone, does that make Modbus TCP less reliable? Absolutely not. And this is the key. The job of error checking is basically outsourced to a much more powerful system, the TCP/IP protocol itself. TCP/IP is the backbone of the entire modern internet. It has incredibly robust built-in ways of making sure data arrives perfectly intact. So Modbus TCP is just piggybacking on all that power and reliability.
Okay, so we've met the original and we've met the upgrade. Now, let's put them head-to-head, a little side-by-side showdown to see how they really stack up.
This table really lays it all out pretty clearly. The physical layer, that goes from a serial cable to Ethernet.
The addressing method shifts from a simple slave ID, just a number from 1 to 247, to a full-blown network IP address. We can see that error-checking handoff from CRC to TCP/IP. And maybe the most important conceptual shift of all, the network model evolves from that rigid master-slave system to a much more flexible client-server model.
And those changes in the model, they have some huge real-world consequences. With RTU, you have one master asking all the questions. That's it. With TCP, you can have multiple clients, multiple different systems, all polling a server device at the same time. RTU is physically limited by how long you can run a cable, while TCP can use the IT network you already have to go anywhere in the building or even across the globe.
And then, there's speed. I mean, wow. This slide pretty much speaks for itself, doesn't it? The absolute maximum speed for RTU is about 0.115 megabits per second. A totally standard Ethernet network running Modbus TCP is cruising at 100 megabits per second, or even faster. It's not just a small upgrade, it's a completely different universe of performance.
So, with TCP being so much more powerful, you might think RTU is totally obsolete. But that's not exactly how it works. In the real world, these two protocols actually have to cooperate. You see, most factories are full of older but perfectly good RTU equipment. You can't just rip it all out. So, the solution is a clever device called a Modbus gateway. It's basically a professional translator. On one side, it speaks fluent RTU over a serial cable to all those legacy devices. On the other side, it speaks TCP over Ethernet. It allows all that old equipment to be seen and controlled by the modern network. It's the bridge that connects the past and the present.
So, I think the real takeaway here is that Modbus is a language that has evolved. It started with the simple, direct dialect of RTU and grew into the fast, network dialect of TCP. They solve the same core problem, communication, but they do it in ways that are perfectly tailored for different technological eras. And that leaves us with one final question to think about. As we move into the future of the smart factory and the industrial Internet of Things, will machines need a brand new language, or will this incredibly tough, adaptable protocol just continue to evolve with them?